Welcome to Stay Brainy, Stay Curious. As promised in the thumbnail, I'll show you that 1 equals 2. You prove me wrong. Ready? Let's go. We're gonna start with 2 equals 2. We can rewrite 2 equals 2 as 3 minus 1 equals 6 minus 4. So far so good, right? Next, I'm going to multiply both sides by -1. This will simply change the signs of all the numbers, resulting in 1 minus 3 equals 4 minus 6. The math still checks out though. So here's where things get a little more complicated. I'm going to add 9/4 to both sides of the equation. I'm doing this for a reason, but you'll agree with me that as long as I add the same numbers to both sides, the equality still holds, right? Okay. So, you might need to refresh your memory on how to solve the square of a binomial. The basic formula is square the first term, minus twice the product of both terms, and then add the square of the second term. So a minus b to the power of 2 is equivalent to a squared minus 2ab plus b squared. Remember this because we're going to apply this formula, except we're going to work backwards. See, in our case, 1 minus 3 plus 9/4 is that final step of a squared minus 2ab plus b squared. Because if a is 1 and b is 3/2, then a squared is indeed 1, 2ab is indeed 3, and b squared is 9/4. We do the same thing with the right side of the equal sign. In this case, our a is 2 and b is 3/2. I'm going to work backwards now and rewrite everything to match the middle step of a minus b times a minus b. All good? And now I can backtrack to the actual binomial of 1 minus 3/2, everything squared, equal to 2 minus 3/2, everything squared. Next, I'm going to take a square root of both sides to get rid of the exponent. Simple enough. Now we're left with 1 minus 3/2 equals 2 minus 3/2. I'm going to take away the negative 3/2 by adding 3/2 to both sides. It will cancel out and become 0, so I'm just going to cross it out. Therefore, my final equation reads 1 equals 2. There you have it. I've proven to you that 1 equals 2. Now you prove me wrong. Where did I make the mistake? Take your time, look at the math carefully, pause if you need to, and we'll go over the equation together in a few seconds. So this is the point where everything started to go awry. I took a square root of both sides and just took away the exponent. Innocent enough, but a detrimental error. You see, you cannot assume that the square roots are equivalent. X squared will be the same as negative x squared, but that doesn't make x equivalent to negative x. Take the example of 36. The square root of 36 can be either 6 or negative 6. Those are two different numbers. So let's take a closer look at our mistake. We have to calculate the expressions inside the parentheses. 1 minus 3/2 is negative 1/2, and 2 minus 3/2 is 1/2. Negative 1/2 is not equivalent to 1/2, so my theory of 1 equals 2 has been completely debunked. So be very careful about taking out the exponents. Always check for negative numbers. Alright, fine. But what if I told you I can prove that 1 equals 2 again using a different method? Ready? Look at this. We're gonna start with 0 times 1 equals 0. And 0 times 2 equals 0. That means 0 times 1 is equal to 0 times 2. Fair enough. I'm going to divide both sides by 1. Again, as long as I'm doing it for both sides, the equality still holds. Next, I'm going to separate some numbers here. I'm going to write that equation in a slightly different manner with 0 over 1 times 1 equals 0 over 1 times 2. This is exactly the same as the equation above, just written differently. All good? So now I can just simplify by dividing both sides by 0/1 to get rid of the fraction. I'm just gonna cross them out. That leaves me with 1 equals 2. Again, I have proven that 1 equals 2. Where's my mistake this time? And the problem is again during the simplification process. Now, don't get me wrong, if this was any other number, we could totally just cross out this fraction and get rid of it on both sides. But here's the kicker, the cardinal rule of no division by 0. And if we look back at our equation, 0/1 is 0. And in order to simplify, we would have to divide both sides of the equation by 0, which is impossible. That means my proof of 1 equals 2 is again bogus. Let me know in the comments if this one stumped you or you saw through it all along. If you liked this video, make sure to give it a thumbs up. Subscribe for more puzzles and riddles. I hope you learned something new, I hope you had fun, and I hope you always stay brainy. See you next time!